This is Chemistry Unit 12, Gases. Next we'll look at volume. The volume of a gas is much greater than the volume of a liquid or solid. And let's compare. So what if you had 1 mole of CO2, which is what you see in this picture. It's not a mole of it, it's CO2. And then what if you had a mole of CO2 that was just in the gas phase? Watch the difference in the volume. The solid has a volume of 28 milliliters, whereas the gas, 25,000 milliliters, right? Because it expands. So this is about the size of a roll of quarters. This is about the size of a large pool, like 9 by 9 by 9, right? It's a big difference. Why do we look at CO2? CO2, if you remember, undergoes sublimation. So it immediately goes from a solid to a gas, and it does not pass through the liquid phase. Okay. The units for volume should look familiar. The metric system unit is the liter, which is L, but you might also see milliliter, centimeters cubed. Y, this is how it can be measured, millimeters cubed or even meters cubed, right? So we originally learned this with liquids versus solids, right? But we can also attempt to measure the volume of gases. Temperature is our next unit. You need to have an understanding of temperature in terms of kinetic energy, and not if something is hot or cold, okay, which we talked about in our last unit. So this is defined as the measure of the average kinetic energy of a substance. Low temperatures means low kinetic energy. The particles do not move a lot, right? So a good example here would be ice, and this is what it would look like in terms of a particle picture, right? Not too much movement. High temperatures equal high kinetic energy. So the particles would be moving a lot. So if you look at the boiling water, right? Look what's happening. Quite different from the picture of the ice, right? Lots of movement. And in fact, you can see how some are actually breaking through the water surface and becoming a gas. The units for temperature are Kelvin. I know we also have Celsius, but the unit that we use for gases is Kelvin. So you have to get used to converting into the Kelvin scale. You obviously can convert out of it, but we do use that once in a while, but most of the time we use Kelvin. So here is the Kelvin conversion. Whatever Celsius temperature you have, you add 273. And we will show you where this number comes from when we talk about our gas laws. Now, if you want to reverse this and go back to the Celsius temperature, whatever Kelvin value you have, you would subtract 273. But this is the one we're going to use the majority of the time, right? So Celsius is used in science and throughout most of the world, but for the gases unit, Kelvin is preferred, okay? So just give this one a try. If you had 100 degrees Celsius, how many kelvins is that? Wait for it, wait for it. You just add. So your Celsius temperature is 100 degrees, add 273, and it's 373 K. If you put the degree or not, it actually doesn't matter for me, but for the most part, we don't put the degree sign for Kelvin. All right, and our last unit is moles. So this is an SI unit itself. The mole represents the amount of a substance. So I hope this looks familiar from semester 1. 1 mole equals 6.02 times 10 to the 23rd atoms. There is something known as a molar volume. So 1 mole would equal 22.4 liters. And you will learn how this number is calculated again a little bit later on in the chapters. Like, where are they getting 22.4? This one I can actually show you. But again, why are we looking at moles? Because we're going to try and figure out the amounts of a gas in certain situations.